For example number 4, we're going to use area. So consider a dartboard. Alright? Now most dartboards are drawn this way, where they have a bullseye in the center, and then if you're close to the bullseye you get a little less points, and then if you're really far away from the center then you get even less points, right? So this is worth, the bullseye is worth 10 points. The next area is worth 5 points. And the last area is worth 2. And then if you don't get anywhere close to the dartboard, then what you're going to get is 0 points. So in other words, if you don't even make it on the circle, forget about it. Okay? And so they want to know, if you throw a dart, your dart is equally likely to hit any side, any point inside the square dartboard, right? Are you more likely to get 10 points or 0? So the question is, are you more likely to text messaging on my thing, to get 10 or 0 points? So I throw one dart, and how do I figure out the probability? Well, the one thing that I know is that the radius of this is 3 inches, and then you go out another 3 inches, and then you go out another 3 inches. So that means I can determine that I have a square that is 9 by 9 inches. So what we're going to do is we're going to do the probability of getting 0 points versus the probability of getting 10 points. So now 10 points. So let me write this out. So the probability of you getting 10 points is equal to the area of the small circle right? So that's the favorable outcome, right? Over the possible outcome, which is going to be the area of the board. So that would be pi r squared versus the side length squared. So the probability of that is equal to pi times 3, because that's the radius squared, all over 9 squared. Wait, let me think this through. Actually, if the radius is 9, then in other words, this is 9, and this is 9, and this is 9, and this is 9 inches. So the radius wouldn't be 9 squared, it'd be 18 squared. Now if we plug that in the calculator, this ends up becoming 9 pi over 324, which is approximately 0.0873. So it's about 8%, almost 9%. Now the probability of 0, we could think of this a couple of ways. I gotta figure out the area of this little chunk here, and the area of this little chunk here, and the area of this little chunk here. But isn't that the total area of the square board minus the total area of the biggest circle? Right? Does that make sense? So the way that I could do that is I could say the area of the board. squared, right? So that would be 18 squared. O minus the area of the largest circle, which would be a radius of 3 plus a radius of 3 plus a radius of 3, which would be pi r squared, which would actually be 9 squared, all over the total board, which would be 18 squared. So if you're wondering where the numbers come from, I have, we have the square minus the largest circle, over the square. So what I'm doing is I'm finding the area of the square, that's this. Then I'm minusing the area of this largest circle, which is pi 9 squared, right? And then the total outcome is the total size of the board. So now what I end up with is I end up with 324 minus 81 squared, or 81 pi, all over 324. That's the probability of getting a 0, which is reduces down to, if you plug that in a calculator, 0.215. So what are you more likely to get? Well, this is 0.08. In other words, I throw a dart, I have an 8% chance. We got like an 8.73% chance of getting 10. However, getting a 0 the probability of me getting a 0 is about 21.5%. So you're more likely to get a 0 than you are to get a 10. Isn't that interesting? Now that's if it's totally random, right? If somebody practices, they're gonna hit the board. That's totally random. If you just randomly throw the dart any old kind of way, and you throw it 100 times, almost 9 times you'll hit the bullseye. But 21.5 times you'll hit the 0 area of the dartboard.